An object, I'm asking for a vector, so direction matters. The symbol I use for position, I typically use X. Now, sometimes textbooks get into if it's horizontal position, it's X, Y, and Z. I use X just as a generic. But it could be Y, it could be Z, R, S. Those are the most common ones. Generally, you see R as the symbol for position when we're talking about some sort of radial position, but it doesn't have to be. And S, chance for someone to show off their trivia knowledge. Why S for position? Apparently no one wants to.
Why, yes. Static.
Stadia, actually.
Huh?
The Roman mile equivalent or analog was the stadia, from which we get stadium, I believe. Anyway, I was told that was the carryover. All right, there's not really a scalar equivalent of position, so we'll ignore that one. The next word, displacement.
Wait, so what was S for?
And S is a symbol that's often used for position, but it comes to us from the Latin word stadia.
Oh, I didn't know if it was for a specific, like, direction or.
No, and a lot of more advanced textbooks will use S as the generic symbol.
Gotcha.
I use X because I've gotten in a rut. Well, actually, I should probably define position while we're here. So position is where an object is, or where, no, we'll go with that one, where an object is with respect to the origin. Let's make this my origin right here. My position is 0. I'm gonna make this as a one-dimensional problem. I'm just gonna walk back and forth. Let's make to the right positive, because, why not? My position is positive.
Now it's negative.
There we go, that's the way the game's gonna be played.
Oh,
In my position now,
Positive.
Positive.
all right. We had 2 voices that time. How about this time? My position now?
Negative.
Ooh, that was nice. All right, displacement. Delta X, delta Y. I'm looking, you're seeing a pattern here. Delta Z, delta Y. Displacement we can have sort of defined 2 different ways, depending upon which one is more convenient. So where an object is, oh, I thought the word is off there. With respect to the starting point. Or change in position. Change typically is represented by a capital delta. That's why I have the triangle in front of all of those. That's a capital delta, and that represents change. When I was doing IT consulting, when we joined the firm, you were either part of technology, process, or people, or change management. And each group had their own name. And the people who were in change management called themselves Delta Force. That's delta symbol for change. Now, as an example of displacement versus position is, let's say I have some sort of axis here, my origin, where they cross, and I start right here. This is what I start. And then I move over to here. In. My displacement, that's my displacement. It's a vector from where I started to where I ended. Yes?
So would a line from the origin to the starting Would a line from the origin to the ending point be your position?
From here to here?
Yeah.
That is my final position, which I would represent by the symbol for position, so just a little subscript F for final. And then to the start, this would be my initial position. There's not a delta there.
Also, is S for displacement still like the generic symbol, or is that just for position?
S, delta, I mean, whatever letter you're using for position, you would use that letter down here.
Yeah, makes sense, okay.
Yeah, it would be very awkward if you used X for position and delta S for displacement. That, yeah, I probably would get you for that.
Yeah.
Be consistent. So notice another thing about delta, change. Change is always, and this is one of those few always that show up. Change is always final minus initial. So my delta X here is the final position minus the initial position. Now let's see if that makes any sense based on what I've drawn here. If the change in position is final position minus initial position, well, if I add initial position to both sides, you know, that whole algebra thing, plus my initial position, that should be my final position. Well, when I add vectors, here's my initial position, new starting point, there's my displacement, and my resultant, my sum of this is from where I began to where I ended, and that is my final position. So it all fits together. Questions to hear?
I just can't quite read the green that you wrote. Did you write the X with the little arrow over it on the two sides, leading to this, down below, yes, is that what you wrote there?
That's an X with a vector symbol over it, and then a subscript F.
Right, and the other one has subscript I.
Yes,
Got it, thank you.
for final and initial.
Yeah, for final, I agree, okay.
So,
Right.
X, like the initial X, that's your position, and then delta X is displacement,
Yes,
right? Okay, cool.
Yeah. You guys wouldn't get so many questions if you had like some kind of convention on what letters you're gonna use.
yeah, I'm gonna also add another convention in just a second here.
Yeah,
What is that?
so you started from that start point and you ended there. But like, what do the letters, like what is the letter right next to it mean, like on the left? Yeah, that one.
Now, that is, I'll try to draw that a little bit bigger and darker. Well, that's not necessarily darker. All right, so that's the symbol that I have written right here. The X with a vector symbol over it is indicating position. I don't have a delta in front of it, so the X, that's the symbol right here for position. The subscript I is telling me initial,
Okay.
the starting, the beginning.
And does that one on the y-axis tell the final?
Yeah, that's technically not on the y-axis, it's supposed to be written next to this vector right here, but that is with a subscript F for final.
Okay.
And I'll be using X of I and X of F a great deal.
But like, why is it there if it ended there?
Because the whole thing is the vector.
Okay.
I'm trying to draw it somewhere in the middle.
You're adding together the position and the displacement to get the resultant, basically.
Yeah, more specifically, the initial position plus the displacement gets me my final displacement, my final position.
Okay.
All right, one more bit on notation. I for initial or starting value, I will use that a lot. I think I tend to use I more than other letters. However, sometimes for the initial, I'll put it O for original, or 0 for when time is 0. Sometimes I will do this for the beginning, instead of an I. I have even, upon occasion, done one equation with an I in it, and the next equation I did an O. Just the way my brain was working at that moment. I think I've pretty much settled on I at this point, but this might pop up every once in a while.
This is exactly what I was talking
Yeah.
about.
So you've been warned, and there's recording here, not who's in the class to have heard it, but let's assume everybody's heard it at this point. Actually. Cool, everyone's here, okay. Anna,
Related to Brooke's question earlier, I'm a little bit fuzzy on what exactly the distinction is between the resultant and the final position vector. It seems like they would be the same.
in this context, yes. Resultant is just a generic term for sum of vectors. In this particular case, the resultant is the final position.
Okay. But it is possible that they could be different, but in this example, they are the same.
Correct.
Okay.
Could you draw an example where they're not the same thing? Cause that doesn't make sense in my head yet, how they could be different.
I have a box with two forces acting on it. Side note, this is an example of other, which we'll talk about later. The net force, the magnitude of the total force. So the magnitude of the total force. They're vectors that I'm gonna add together. I have 18 going this, 18 newtons to the right. I have 24 newtons going this way. I'm gonna add the two vectors together, and that, using Pythagorean theorem, that's 30 newtons. My resultant is 30 newtons. In this context, my resultant is also the magnitude of my total force. In both cases, the resultant is just the sum. I add vectors together, I get a resultant.
But it's not the final position.
No, this is definitely not.
Okay.
These are dealing with forces, these are dealing with position / displacement.
Would the resultant in this case be just 30 newtons, or would it be 30 newtons, 30 degrees, like that?
The full answer, the resultant would be 30 newtons at some angle.
Okay.
That's why I
Whereas
did the absolute value to indicate magnitude of result of total force. Magnitude is all I'm looking for, is just that number.
And if we were talking about the final position, would that be listed similarly, where we have to say the degrees and the magnitude and all of that?
Or give I and J components of it.
Okay.
So there is no final position when it comes to forces, like that's just not gonna be something we're worrying about.
We could relate them, but,
But that's too complicated, so.
well, not by the time we get there. You have an object here. Forces are applied, starting at rest, forces are applied. After 2 seconds, where is it?
Up there.
So you use forces in order to figure out the acceleration, which we'll get to. And once you have the acceleration, you'll figure out what the final position is.
But I'm kind of like confused on that triangle that you drew there. So if it started there, you know, and then ended there, then like where are the other lines? Like is that, like I'm not sure what the other lines have to do with where it started.
From the origin.
It's from zero.
Yes.
So,
So position cares about where you are relative to whatever the origin is.
So then like what do the green lines like represent?
Positions. Their position, it's where, this x sub I here is where the starting point is relative to something we decided was the origin.
Oh,
And x sub f is where you end up relative to
okay.
there.
I wasn't thinking about like the origin. I was just like looking at the, yeah, okay.
Yeah, so definitely, the origin there these two hit the origin on purpose.
Okay.
So for the sake of the game we were playing, I'm going to make I'll put it over here. That's my starting point. So right now, so assume I've started there, whenever I do this bit of exercise, assume I've started there. My position, positive or negative or zero?
Positive.
Positive.
We have
It's
it.
negative to the origin.
Oh, I
Yes,
thought,
Oh,
what's,
that's it.
wait, what did you just say?
I asked, that's coming up. I asked about my position,
Sorry, it's negative.
so, yeah, it's negative, because I'm on the negative side of zero.
Okay.
My displacement,
Is
It's to the
positive.
right of your starting point.
yes, and therefore positive. All right, people seem a little unsure on that one.
Oh, okay,
Wait,
okay.
so you said
These are
position?
two different questions. One's what's my position, the other one is what is my
The
displacement?
displacement, yeah, because that's relative to the origin, that's negative, and then if your starting point's over here.
Yeah.
Then the vector moves positive. Okay, that makes sense.
Right. So, some people get, there's gonna be a, complex version of this on the first test. Don't worry, we'll do an example before we get there. And some people just get position and displacement completely backwards. So, some say the sillier the memory trick is, the more you remember it. Ocean Pacific. Opulence. Zero protocol. The origin and position are associated with each other.
There's also an O in position, so you can make that.
There we go.
Zero.
All right.
And
I
then-
just thought of the juvenile memory trick related to that, but, fill your own in. All right, yes, there's another question?
No.
In total, is it just position is where you're at and displacement is where you went? Or is it different from that? Because position is more of a, does position have a direction or is it
Oh,
just?
yeah, and it's a vector, so it has a direction.
Or is it stationary?
One end of it is stationary, like, because it's at the origin. One end will always be at the origin, and then the other one will be wherever your dot is.
Yeah. So if I make the origin that corner over there, then, think of there's an arrow going from that corner to where I am, and that arrow is constantly changing length and direction as I walk around. My
Right,
position is changing,
right, okay,
but the end is fixed.
right. And so your displacement is the change in, where your position was to position end.
Yes.
Okay.
All right, anyone else?
Wait, I'm so sorry. I suddenly lost track of how position can have magnitude. Like if we look at this triangle you drew over here and you either start and your end, and you're gonna have one vector there representing some magnitude in some direction. And I understand how the position vector would show, like I guess I can see how it would have an angle, but I'm confused about how it would have magnitude.
All right, so think about it this way. Think about where you were born. If you can pin it down to the building, great. But think about the town you were born in, if you can narrow it down more than that. And think about where you are right now. How far are you away from that?
About 3,500 miles.
Okay, so that would be the length. If you consider where you were born to be the origin, then that's how you get a length. It's just how far you are away from it.
The length is.
Just.
Yes, length and
Yeah,
magnitude
that makes sense.
are often used interchangeably.
Yeah, okay, got it, I'm here.
And, how else are you gonna describe your position if you don't have a reference?
Right.
Reference being the word.
And what you choose to be, ultimately, what you choose to be the origin, unless it's given to you, which it will be on the complex version of what we're heading towards, you get to choose what the origin is. You could consider, not necessarily the easiest way to do it, but you could consider yourself to be the origin. And your position never changes. Everyone else does.
Is that related to the whole, when you talk to people about physics, you have to assume that you were right concept? I feel like those are related.
No, they assume that you're right is just an arrogance thing.
Yeah.
No, it's just relativity.
there's a good bit, we're trying to figure out what you wanna choose as the origin or the reference frame is get to more sophisticated versions of this. Choosing a reference frame to make the math easier, you would spend more time on. If you pursued physics at graduate or senior level or graduate level physics, you would then try to go through and try to figure out what coordinate system and origin would make the math as simple as possible. And so you do have some, you have some say so. I'm gonna be various times of when I'm gonna ask, why is that the origin? And you can just say, because I say so. Olivia?
Good question. Okay, so this is physics, but what is quantum physics like?
All right,
He's gonna go off on a.
quantum physics, I generally hit near the end, if we have time. I don't always have time, but if we have time, I've done quantum physics for 152 before. Quantum physics is the point where I go, all that stuff you've learned is just a little bit off, and it gets even more bizarre.
Well, that's annoying.
So,
Have to get away from Newtonian physics.
if I took a ball and I bounced it, the angle of incidence equals angle of reflection. You know, the angle in which it hits the floor, it'll bounce up at pretty much the same angle. That's mechanics, that's Newtonian mechanics, that's the stuff that we're doing now. Assuming no spin, perfect balance, let's just throw out anything that would cause it to
Yeah, it's a straight
Heck,
line.
Coriolis.
Now, in quantum physics, you would go, all right, I bounce the ball, it hits that, and I can tell you the probability it's gonna bounce at that same angle, but there's also a probability that it's gonna do something really bizarre. And it's not till you observe it that it actually is gonna do anything. If you don't observe it, it does it all, simultaneously.
Is that what works that way?
Yeah, that's William Schrodinger. Pardon?
What?
I heard somebody say something.
I said you gotta collapse the wave function.
Absolutely. So, are you glad you asked?
Why did I ask?
Are you glad you asked?
I mean, I was just curious.
Yeah, quantum physics starts dealing in the realm of, it's heavily statistics related.
Like literally questioning everything ever.
Yeah,